are some questions from the past papers. This question, he didn't draw the curve. He wants me to draw the curve. He gave me the curve, he names it C1, and now let's read. The curve C1 has equation y equals x squared, open brackets, x plus 2, close bracket. It means it's a cubic curve, and the cubic curve, we'll take it in functions afterward. It is a curve that is going up, but sometimes it has humps. If it is y equals x cubed, it's smoothly going up, but now it has humps because there is x squared into x plus 2. First of all, he wants you to find the gradient of the tangent to the curve at any point. This is generic. The gradient of the tangent to the curve at any point, it's dy by dx. We cannot find dy by dx unless we expand. Expand, then differentiate. Expand, then differentiate. Let's expand. Okay. Take care of the titles. So now question A. Here is y equals x cubed plus 2x squared. If you expand, when multiplying, add powers. Then we need to find dy by dx. It is power goes down, decreases by 1, 3x squared. Power goes down, it will hit the 2. So it is plus 4x to the power of 1. Power goes down, decreases by 1. Next step, he wants you to sketch C1. Sketch C1 showing the coordinates of the points where C1 meets the x-axis. So how to find the points where it meets x-axis? And he needs coordinates. It means x and y. Y coordinate, 100% it's 0. What do you know about these 2 points, dears? We know that they lie on x-axis. So what? Their y's are 0. So you just put this point, it's y equals 0. This point, it's y also equals 0. So you have to prepare the coordinates. It is something, comma, 0. And the other point, it looks like the origin. Is it 0 and 0? Of course, we can know it like that. It is 0, comma 0. Let's know how to find it out. You just put y equals 0 in the equation of the curve. So I'm speaking now about part B. Just put y equals 0. So it is x squared into x plus 2 equals 0. Oh, it's solving quadratic equations. No, it's a cubic equation. Anyways, 0 equation, then factorization. Factor multiplied by factor equals 0. Either the first factor equals 0 or the second factor equals 0. It means x equals -2, which is this point, or find square root for both sides, x equals 0, which is that point, 0 and 0. The third part of the question, underline to make it neat. The third part of the question, he needs me to find the gradient of the curve, C1, he called it C1, at each point where C1 meets the x-axis. You have to expect, if you draw a line here, a tangent here, gradient of the curve means gradient of the tangent to the curve. Repeat, gradient of the curve means gradient of the tangent to the curve. What's written here? Gradient of the curve. It means gradient of the tangent to the curve. What about the gradient at this point? We said before that the gradient of the tangent to the curve at the minimum point or at the maximum point is 0 without calculations, because difference in y's over difference in x's, difference in y's is 0. So how to find the gradient of the curve at, if you name it point A and point B, it will make it easier for you. This is point A and this is point B. Now let's start. We'll say now here at A, where x is -2, the gradient of the tangent to the curve is simply dy by dx, which we got it before, at the point which is x is -2. You'll simply substitute where here. You need to put it in a box because you will keep searching for it. So now it is 3. How to substitute? In brackets. Remember, 3 brackets squared plus 4 brackets. Copy and paste. What shall you write here? The value of the x, which is -2. If you multiply 3 by -2 squared, it means you are multiplying 3 by 4, positive 4, minus 8. So it will be 4. Did you expect that the gradient of the tangent to the curve at point A will be positive? Yes. Gradient at A is positive 4. And what about gradient at B? Gradient at B, no need to calculate it. It is 0 because it's a horizontal line and your sketch is correct. Now we have here another question. This is having various types of terms. Here is x power 3, here is x power fraction, here is x power 1, and here is a constant. First, he wants you to find the first derivative, and then we'll practice how to find the second derivative. It's the derivative of the first derivative. Now let's go. Power goes down, decreases by 1. Say it, power goes down, decreases by 1. Okay? Now dy by dx is 15 x to the power of 2 minus, you multiply 4 over 3 by 6, 8, minus 8 x to the power of, then 4 over 3 minus 1 is 1/3. This is how it comes. Then plus 2x, you will just write it plus 2. Then minus 3, it's a 0. It will vanish because 3 is constant. -3 is constant. After finding the first derivative, now we need to find the second derivative. d2y by dx2. Don't say d squared. It's not squaring. And don't say d squared y by dx squared. You are squaring nothing. We call it the second derivative. It is d2y by dx2. Power goes down, decreases by 1. 2 times 15 is 30. X to the power of 1. And here, power goes down, decreases by 1. It is 8/3. X to the power of 1/3 minus 1 will be -2/3. What about the 2? The derivative of the 2, because it's constant, it will be 0. I prefer taking a question. This one is repeated. Let's take a question which is different. Okay. A curve with equation y equals f of x passes through the point 4 and 9. Given that the derivative is already given, f dash of x is given. Let's read. The curve y equals f of x. Do you know the curve equation? No. But he gave me already the first derivative. Thank you. He gave me it. He differentiated for me. Thank you so much. After he finished writing this, what's the requirements? Point P lies on the curve, and the normal to the curve at P is parallel to the line so and so. Find the coordinate of P, x coordinate of P. So now, what's your plan? We need x coordinate of P. What do you know about this P? The normal means the perpendicular to the curve at P is parallel to the line so and so. First of all, put this line, put it in the form y equals mx plus c, y equals mx plus c, just to know its gradient. Put it in the form, this line will be 2y is equal to -1x, and then divide both sides by 2. So this line, we put it in the form y equals mx only. There is no c. No problem. What do I need from this line? I just need to extract its gradient. Y equals mx. The gradient is the coefficient of x. So this line, its gradient is -1/2. the first step is the gradient of the line is negative half, and the gradient of the perpendicular will be positive 2. Remember from the chapter of straight line graphs, the perpendicular line, which we call it normal here, the normal has negative the reciprocal gradient. Then the normal to the curve at P is parallel to the line. So parallel lines have same gradient. Parallel lines have same gradient. But it is normal to the curve. No, I'm sorry. We have to say it first that the gradient, the second gradient, is equal to the first gradient, and both of them have the value of negative half. But the gradient of the curve, it is normal to the curve. Okay, we'll understand the word normal afterwards. Take care of the word parallel. It means both of them have the same gradient. Parallel lines have same gradient. This gradient is negative half, and the normal is also having a gradient of negative half. But it's normal to the curve, not tangent. Normal means it's perpendicular to the tangent. Okay, so now you need to know the gradient. This is the gradient of the normal. Gradient of the normal. What about the gradient of the perpendicular? What about the gradient of the tangent? So the gradient of the tangent will be positive 2, which is negative the reciprocal of the normal. Why do we need the gradient of the tangent? Because all we took before was speaking about the gradient of the tangent to the curve. This is dy by dx, okay? dy by dx, it is the gradient of the tangent to the curve. You equate it to 2. Equate, then solve. Solve what? You formed an equation now. Do you know dy by dx? Yes, I know it. It's written up. It is 3 square root of x over 2 minus 9 4 square root of x plus 2 is equal to 2. Wow, it's cooked nicely. When you shift this 2 to the other side, it will be negative 2, so it will be a 0. So we have here 3 square root of x over 2 minus 9 over 4 square root of x is equal to 2 minus 2, which will be a 0. Why don't you shift this to the other side and sing fraction equals fraction, then cross multiplication, like that. So 3 square root of x over 2 will be equal to 9 over 4 square root of x. 3 square root of x over 2, 9 over 4 square root of x. Now we sing fraction equals fraction, then cross multiplication. 3 multiplied by 4, it's 12. And square root of x multiplied by square root of x, it is x. And 2 multiplied by 9 is 18. And divide both sides by 12 is 3 over 2. This is P. Point P. X coordinate. Ta-da-da!